Good morning. We are from Maryknoll School. I'm Shelly, and she is Sibi, and this is our honor to attend this oral event. And our topic is Are gray code and growth sequence the solution of Chinese ring? First, I want to talk about what is Chinese ring. In my hand, this is the 9-ring Chinese ring, and this is the 5-ring Chinese ring. And now I'm going to talk about the mechanism of the Chinese ring. It has two rules. The first rule is the first ring can be off or on all the time, and the second rule is, for example, we need to take off the 4th ring, and the 3rd ring must be on, and the 1st ring and the 2nd ring must be off, so that we can take off or take on the 4th ring. Now, I'm going to talk about the notation of Chinese ring. We will let n to represent the total number of ring. We will let s to represent the step that we're working on, and r to represent the ring that we need to move at step s. Now, we will let this ring will be the n. Near the handle, this is n, and at the opening, this is the first ring. We will use 1 to represent it. Now, I'm going to talk about how to solve a Chinese ring and the total number of steps to solve the Chinese ring. We will use mn to represent it. Now, I'm going to solve the 5-ring Chinese ring. And we may see that in a 5-ring Chinese ring, there has totally 21 steps to solve all the ring. And in the 9-ring puzzle, there has totally 341 steps. And I'm now trying to solve it, and please give me some time. And at last, give me some, and we can use the formula to solve it. We can put the total number of ring into the n, and then we can find the total number of steps. And now it is solved. We may see that if here is the 20th ring of the Chinese ring, the total number of steps that we need to take off the ring will be this number. It is a very large number. So we may think that a lot of people will feel difficult in playing the Chinese ring. So we have the first idea. Our idea 1 is we want to have a function that is represent the ring which is on or off. For example, when the total number of ring is 9, we focus on the 23 step, we will use the binary number to represent it, where 1 means the ring is on and 0 means the ring is off. We list all these numbers. However, that is called gray code, so our topic is done by the others. Hence, we have the idea 2. Now, we want to have a function that is equal to the r, such as when the total number of ring is 9 and we focus on the 21 and 22 step, the changes of 2 step is the 7th ring. So, we write down the number of 7. We list out all the number. We focus on the 21 and 22 step. We may see that the changes is the 7th ring. So we list out all the changes number. However, when we count the number from the bottom to the top, that is called growth sequence. And we do more further reading, we found that a lot of books have mentioned about growth sequence. However, we can't find any proof about it. A lot of books said that it is observed that they are identical to the solution of the puzzle. However, we think that observed in a mathematical part is not acceptable. So we want to prove it, and we have the third idea. We found that growth sequence can be represented like this. And if we can prove that the reversed growth sequence is equal to the r, then the reversed growth sequence is the solution of Chinese ring. How to prove it? We can use the a function and put the reversed step into it. And if the result is equal to the r, then the reversed growth sequence is the solution of Chinese ring. But first of all, we need to find the relationship between s and r. We may see that now here is the first tick down, and after the first tick down, it has the repeating interval. We may see that it is the same amount. And now, we are going to find the first tick of the ring and the repeating interval. Because due to the mechanism of the Chinese ring, odd and even number is different. So we separated into 4 cases. Now we are going to do the case A and case B first, where n is equal to odd. The first step to take off the ring will be like this. And this is the R equal to odd. It is the general case. And it is the R equal to even. It also is the general case. So now we have found the formula of the first tick of the ring, and now we are going to find the repeating interval. It is the general case of repeating interval of n is equal to odd. Now we have found the 3 cases of it. This is the 2 to the power r is the repeating interval. Hence, we have found the first tick of the ring and the repeating interval. So we can think that the first repeating interval is equal to the first tick down plus 0 times 2 to the power r, and the second repeating interval will be the first tick down plus 1 times the 2 to the power r. So we will use the k to represent the multiple, is such as s is equal to the first tick down plus k times 2 to the power r, where k is an integer. This is the formula. Since s is equal to the first tick down plus k times 2 to the power r, and s is equal to this formula. So now we can put the step into this formula, and we put that into this formula, then the result is really equal to the r. Now we have done the case A. We are now going to do the case B, where r is equal to even. The result is really equal to r too. So we have done case B also. The first step to take off the ring when n is even will be like this. And the repeating interval also is the 2 to the power r. So we can write that down and these 2 formula into the function of a. So at last, it's really equal to r. Hence, we have done the case C and case D also. We have done all the proof. Now I'm going to talk about the relationship between row sequence and the gray code. In each of the 2 gray code, there has only have one changes. And such as this, we may see that the changes is the number of 2. So we may see that if the reversed row sequence is the solution of Chinese ring, then the gray code is also the solution of Chinese ring. We may see that nowadays in the 2012, a lot of people will use a Chinese ring into the biomolecular structure. And in the 2015, a lot of people will use the gray code and row sequence in the distributed computing. So we think this solution, and we want to help more people to solve more problems. And this is the end of our presentation. Thank you for listening.
Thank you.